Hi friends, welcome to our channel. Let's have a look at problem 4006, count valid prefixes. So the purpose of this video is to demonstrate the simplification of the coding. So first, let's quickly look at the problem statement. So here we are given a binary string. So a prefix is considered valid if its characters can be rearranged to form an alternating string. So we want to return the number of valid prefixes of S. So here a string is considered alternating if no two adjacent characters are equal. So here the main point is that the characters can be rearranged, right? So this is the main point. So let me remark here. So because it can be rearranged in order that the string is alternating. So we either have something like this, right? Ending at 0 or 1, whatever. All start from 1, 0, 1, 0, ending at 0 or 1. But the common pattern is that the number of zeros and ones can have a difference by count at most 1, right? So the absolute value of number of ones and minus the number of zeros should be less than 2. This will be a valid alternating string after rearrangement. So in other words, the main method will be a linear scan. During the linear scan, we count number of zeros and number of ones. So first, I'm going to do it using 2 variables, and then I will reduce it to 1 variable, right? So first, I'm going to initialize a result variable. So this is the counting of the number of valid alternating prefixes after rearrangement. Then we're going to iterate. So here I'm going to count the number of zeros, number of ones. So initially 0, right? Then we iterate. So for I character in enumerate S. So first, if character equals 0. So in this case, I'm going to increment the count of zeros. Otherwise, because it's binary, so I'm going to increment the ones, right? So at each index, so starting from index 0 to the current index I, it's possible that this prefix is a alternating one. So we're going to check, right? If absolute value of number of ones minus number of zeros is less than 2, so we're going to increment the result by 1. So finally, we just need to return the result. So let's run it. Yeah, it passes the 2 cases. Now let's look at the generic case. Yeah, it passes all the cases. So now let me write another solution. So, but the structure will be the same. Here, in this version, I'm using 2 variables. Actually, you know, what you want to modify or monitoring is just the difference of number of zeros and number of ones, right? So here we can use 1 variable. So let's say we use monitor, right? Monitor count. So if this is the case, so I'm going to do the monitor increment by 1. Otherwise, the monitor is decremented by 1. So in this case, if the monitor is less than 2 in the absolute value, so we are going to increment the result. In other words, the monitor variable encodes the informations carried by n zeros and n ones. In other words, the first version contains more details, right? So it can have a running count of zeros and ones. But in the second one, because of the purpose of this problem, we're just counting the differences of number of ones and zeros. Let me run it. Yeah, it passes the 2 test cases. Now let's submit. Yeah, again, it passes all the cases. So here, from this problem, I want to demonstrate that. So when you do the coding, it's best to take an iterative way. You can first write some solutions which contains details, and then you make it more compact, and ideally, so you can use some abstraction so that you can generate your solution, so that your practice yields maximum results. With that said, thank you for watching. That's it for the current video.